So please, Professor Borga.
Oh, thank you very much. Thank you, Karina. Thank you all for the kind invitation. Well, this talk is about a twin response of flash flood inducing storms. On one side, a hydrological response that we have already, for instance, described from the talk by Maria Elena, and also the geomorphic response, so the one that is due to shallow landslide, debris flow, and also from boat transport as well. For this talk, I like to acknowledge the contribution by Francesco Comiti from University of Bolzano, Italy, Nicola Surian from Padova as well, and Lorenzo Marchi from CNR ERP from Padova as well. So why I'm trying to understand both hydrologic and geomorphic response is important. For a couple of reasons. We can move to the next slide, Karina, if possible. Thank you. So the reason is twice, as I told you. From one side, in the past decade, there was a lot of attention on what we call the opportunistic post-flood surveys. As you well know, flash floods are really difficult to monitor, both in real time and as post-event analysis, because their space-time scales doesn't agree with typical conventional hydrometeorological surveying. Therefore, we need to collect field-based data in order to retrieve indirect peak discharges, and we developed a number of methods for this, with also trying to tackle the uncertainties in these estimates. Then there was attention to the combined use of post-flood surveys and hydrologic modeling in order to refine the accuracy of post-flood surveys, and be able in this way to discard either bad data or bad results of hydrologic modeling. All these led to understand the impact of geomorphic changes, both in the landscape and in the river network. And therefore, this was taken as an opportunity to combine the analysis of the hydrological response with the geomorphic response, and also trying to understand trying to collect data on boat transport data in order, from one side, to refine our way to survey in the post-event fashion flash flood events, but also to collect key data for flood risk management in basins where particularly because they are of complex orography and are forested, geomorphic processes and boat transport plays a key role in shaping the flood risk, both in real time and also in the management of the flood for preemptive measures. We can move to the next slide, please. This is just a short introduction to what a post-flood survey is. So we are just taking high water marks. This is the top images. Then we are surveying the bed in order to the river bed in order to collect information about the geometry of the river and also on the hydraulics property of the river. And then we are applying simple to complex hydraulic models in order to derive peak flood estimates that correspond to the river geometry and to the high water marks that were field observed. We can move to the next. During these surveys, we might see that the rivers might exhibit very different types of geomorphic effects. From A to D, we are able to see very major geomorphic effects, for instance, in A, where the whole riverbed was remodeled by the flood. And this is particularly important because during past post-flood surveys, one key assumption is that the geometry of the river we are observing in a post-wave fashion is the one that witnessed the peak flood. So if a riverbed undergone an important remodeling with erosion and deposition, clearly this places severe questions on the accuracy of our estimates. On the other range, on D, we are seeing that with artificial structures, this type of uncertainty is severely constrained with very negligible impacts of geomorphic effects. We can move to the next. Next slide.
Sorry, I had to share my screen. Okay. Otherwise,
well, this is a complex diagram that can make very simple at the end, where we are describing how we can take into consideration observation from the field concerning geomorphic impacts in order to discard what are really not water flood and contrasting with water debris flow or hyperconcentrated flow, which requires a completely different treatment. And how by using a parallel analysis, by using radar rainfall estimation and rainfall runoff models applied to the same context, we are able, taking into account uncertainty, to discard what can be bad observations that may lead to bad peak discharge runoff, peak discharge estimates that are not correct, or what could be considered bad runoff models that were not consistent with the field observation we made. So this analysis, which take into account uncertainties, is key to preserve both the observation consistency with the model consistency. With the next slide, this is an example. These are three examples from a paper that was published last year and with a collection of data from extreme flash flood in Europe and in the Mediterranean context. And three of these flash flood occurred with important geomorphic impacts. These are all located in Italy, and were analyzed by taking these geomorphic impacts in real considerations. We can move to the next. This is a case that happened in Sardinia in 2013, and this was the first case where we considered the geomorphic impacts into real consideration. You may see the bridge that was destroyed in the top left picture, the bridge that was destroyed by the flood. Therefore, we considered the uncertainty in the post-flood survey, the uncertainties in the model, and we try to integrate both of these uncertainty by considering, for instance, the catchment area as a main control variable. Then we can go to the next. And this is a result of how trying to analyze observation and results from the rainfall runoff models might lead to spot where some specific peak discharges may be wrong. You may see these are in the bottom figure. The two continuous red lines embraces the observations uncertainty. So the uncertainties that are bounding the observations. And you may see also the uncertainties in the box plot, the uncertainties affecting the rainfall runoff analysis, the rainfall runoff model output. And for the analysis that were considering for the three smallest basins, you may see that the uncertainties and the observations are completely falling outside the model results, and this led to discard these three different observations. And this happens frequently for very small basins for which both radar estimates might be wrong, because simply the radar was not able to spot the real intensities in those particular circumstances, or for small basins where geomorphic impacts in form of channel disturbances or debris flow are particularly important. We might go to the next. And now we are just tackling the concept of boot dynamics during flash flood. Very little is known for these processes, but we know that they have a key role in both post-flood surveys, because they might really induce errors in this type of estimates, but also they place a very important role in flood risk management plans. Just 4 pictures from ancient times to very recent episode. The last one is one occurred in Piemonte last week. It's a picture from that flood. We see that this type of transport might lead to clogging of bridges, and therefore to inundation due to the increasing level of water that these enhance, but also the type of damages this type of transport might induce might be really important, as you might see in the second picture in the top level. We might move to the next. Well, this was a movie that cannot be shown in this PDF video, where we were able to monitor the process of wood recruitments during floods. This process was due to bank erosion. And, well, the movie was particularly interesting because it was able to capture the enlargement of a river section exactly related to bank erosion that induced a lot of boat recruitment. So during these post-flood investigations, we are doing what we call boot budget during the channel, and we are considering recruitments and distinguishing how the recruitment is made either by bank erosion in the form of fluvial corridor or by lateral recruitment in the form of landslide and debris flow that interface with hillocks. So with this type of measurement and surveying, we are able to produce a budget for flood events that, and then we can go to the next slide. We were replicating the same concept on several flash flood theaters in France, in Switzerland, in Italy, and in Austria as well, and in Taiwan. Making a picture of the results from all these post-event analysis produces some interesting output. We can move to the next. For instance, this is a picture concerning a collection of data that we produced based on observation of all the catchments that I mentioned before. So in the first diagram on the top, you may see the large wood transport volume in cubic meters related to the catchment area. When we produce the specific large wood transport volume by dividing this by the catchment area, we might have the second diagram you may see in the bottom. You may see that in this case, we might have for a catchment area of 10 kilometers square, we might arrive to 300, 400, and even up to 500 cubic meter per kilometer square, which is a lot because when this transport might interact with man-made structure, artificial structure, this might really produce disasters in terms of clogging of the structure. Then you may see the upper envelope curve in the form of this power type relationship with the area, which is pretty interesting. We might go to the next. We may go to the next. Yeah. Here, no, sorry, the previous one. I was delayed. Yeah. Here, it is interesting because the upper envelope curve for the wood transport volume basin area show a scaling relationship with the area with a power exponent 0.6. And this is pretty similar to the envelope, to the power relationship concerning the envelope curve retrieved from a unit peak discharge basin area observed across the Mediterranean and European framework. But if we go to the alpine areas where these wood transport data were retrieved, we might see that the power is exactly 0.6, exactly corresponding to the power relationship that we have seen for the wood volume basin area upper envelope curve. And this is particularly interesting, showing that it is simply the peak discharge that might control the relationship between the transport of wood to the in relation to the basin. We might move to the next. Other important observations concerns the area where this wood is recruited. Here we see two flash flood impacted basins, Polieschina, 25 kilometers square, and Gravegnola, 34 kilometers square. They are in the close to the Liguria to Tuscania borders, and were severely impacted by the Magra 2011 flood with a lot of wood transport. And what you might see here is the redistribution of recruitment from floodplain, slopes, and the role of deposition. What you might see is that consistently in the heat waters, recruitment from the slopes in light red is dominating, while more we move to the valley and to large basin area, the recruitment from the floodplain becomes more and more important. And also more we are moving to artificial structures. So more we move to the floodplains, more important is the deposition that is occurring mostly at the clogged bridges, plus at some standing trees and on artificially narrow cross sections. We may move to the next. And therefore, we have some conclusions. This is just to remind that post-flood surveys play a key role in our understanding on the dynamics of flash flood, and they are particularly important to shed light on hydrologic and geomorphic response. Uncertainty is very high, and it is particularly high when geomorphic impacts are severe, and therefore we need to analyze this aspect as well. And for this combination of different observations, some of them concerning geomorphic impacts and modeling approaches, is key in order to confine uncertainty and discard bad observation or bad modeling output. We can move to the next. IPEC, so these intensive post-event campaigns are also key to collect data on geomorphic processes and boot dynamics, which means both just the boot transport, but also the requirement places of wood and the fate of wood during large flood. As a first summary of these research, we have seen that recruitment from heathslopes is more relevant in headwaters, where confined channels are dominating, and whereas floodplain erosion dominating in unconfined channels. And wood transport in large rivers during flood is mostly limited, and therefore we might observe deposition, particularly where we have artificially narrow cross-section and bridges. And that's all for this presentation, and thank you very much for your attention.
Thank you very much, Marco, for your presentation. I'd like to open the floor for the people here, for the other speakers. Do you have any questions here in the speakers room?
I have one. Maria Elena Ramos speaking. Can I ask the question?
Yes, please, Elena.
Hi, Marco. Thank you for this presentation. A lot of experience with this kind of complex situation. So I was wondering about the forecast in such debris flows and such a large amount of wood transport. Given the complexity of all these elements involved, do you think that we can forecast such events also at the same time we're forecasting flash floods? For instance, we saw here in this last event in France and Italy, we had a lot of things on sediments and also erosion and going on in many of the rivers. So what's your opinion about the forecast in such complex situations?
Well, in general, we can forecast the susceptibility to this type of events, even though forecasting the precise occurrence of debris flow, and in many cases debris flow are leading to important wood transport, is very difficult, because these are really local processes that requires forecasting events and processes at the scale of less than 10 kilometers square. Therefore, this is particularly difficult, and why we might forecast the susceptibility to this type of events at the scale of 100, 500 kilometers square, going to the detail of forecasting where and when this type of processes will happen remains very difficult, at least based on what we observed in the past events this year, and on the data we are needed in order to understand what happens in the frame of the post-event analysis.
Okay, thank you.